Now that we've derived the formulas for surface area, we can begin to use them to calculate the surface area. So in our first example, we have a sphere, and they give us the radius of that sphere. So we're going to begin with the formula for surface area. And we have 4 times pi, which is a constant, times the radius squared. So we're going to take the value of the radius and we're going to substitute it in for r squared. And then we're going to enter this into our calculator. And when we do that, we end up with 511,201,962.3 square kilometers. And remember, because we're dealing with surface area, we need to include square units. In our next example, we're looking to calculate the surface area of a pyramid, and we're told that this particular pyramid happens to have a square base. So the first thing we want to do is draw a sketch so we can label some of the dimensions that are given to us. Now, in order to calculate the surface area, I'm looking for the area of all faces. So I can see that I'm going to find the area of the square base, and because it's a square, I know that these lengths are all going to be the same, which means my 4 triangular sides will also all have the same area. So using what we know about how those formulas are derived, we're going to kind of manipulate this. So I'm going to find the area of the square on the bottom. My 4 triangles are all identical, and I'm going to find the area of each, base times height divided by 2. Now I put slant height instead of height, just so we remember we're not using the height of the pyramid. What we're actually looking for is the height of each of those triangles, which is the slant height of the pyramid. I know the height of the pyramid is 40 meters, and I also know from the center of the pyramid to the edge, it's going to be half the distance of the length of the base. So if the base is 60 meters, from the center to the edge is 30 meters. And then I can also see that this is going to form a right triangle. I can find any missing side in a right triangle using Pythagoras' theorem. So we're going to set up a squared plus b squared equals c squared, the hypotenuse being the measurement that we're looking for. So I'm just going to go ahead and manipulate this. So I want to isolate s. I'm going to square root to get rid of that squared. And when we do that, 30 squared is 900. 40 squared is 1600. Add them together to get 2500. And then when we square root that, we get 50 meters. So 60 meters times 60 meters is going to give us the area of the square base. And then we have 4 triangles. The base of each triangle is 60 meters times the height of each triangle is that 50 meters we calculated. So we can substitute those dimensions in here. And then we know that 60 squared is going to be 3600. And then what I would do is we can see 4 divided by 2. So I would probably just go 4 divided by 2 is going to give us 2. So we're going to have 2 times 60 times 50. So that's going to give us 2 times 3,000 plus the 3,600, and we end up with a total surface area, all 4 faces including the bottom, of 9,600 square meters. We're now asked to calculate the surface area of a pop can in square inches. They give us the diameter and the height, however, in centimeters, so we're going to have to do some conversions. The first thing you want to do always is draw a sketch and label the dimensions given. So we have the diameter, we also have the height, and so in order to calculate surface area, we're looking for both the area of the top and the bottom circles, as well as that base that's going to be a rectangle if we were to unravel it, so to speak. So we're going to begin with the formula for surface area, and even though they give me the diameter, I know that the radius is half that. So if I take 7 divided by 2, the radius is going to be 3.5 centimeters. So I can substitute that in for radius, and I know that the height is the 12 centimeters. So let's go ahead and substitute that in. And then in your calculator, you can just enter all of this. If you have a TI calculator, it will do order of operations. So use the pi button, punch that in, and we're going to end up with 340.862 square centimeters. Now, some people like to calculate these two values into inches right away, and then from there, just enter them into the formula. That works, but I want to show you how you can do this a different way. If you were to convert both of those into inches, notice that you're going to be doing 2 conversions. You're converting both the diameter as well as the height. So because we're looking at area, remember that we're going to end up squaring that conversion factor. So we're going to divide by 2.54 square centimeters because, again, there are 2.54 centimeters in an inch. And you can always go over to the side here and say, okay, 1 inch contains 2.54 centimeters. We have 340, etc., square centimeters here. So we're going to be multiplying by 1, which doesn't change the value, and then dividing by the 2.54. Remember, square units, we're squaring that conversion factor. We're applying it to the height as well as the diameter. So we're going to leave this value in the calculator, divide by the 2.54 squared, and we're going to end up with 52.83, etc. square inches. It doesn't say what to round to in this particular question, so I'm going to leave it as an exact value. In our next example, we're actually given the surface area of a box or a rectangular prism, and we're asked to calculate the height. Now, even if the question did not say sketch a graph, we would be sketching a graph. We're going to label the dimensions that are given to us, and we're looking for the height. So I can see that it's a rectangular prism. We're going to begin with the formula, and because they give us the surface area, we can actually substitute that in for this measurement. And so then we're going to substitute in the length and the width, which we know, and the height we're just going to leave as a variable in each of these cases. 5 times 3 is 15, times 2 is going to give me 30. And then if I simplify each of these terms, I've got 2 times 5 is 10, times h, I'm just going to leave that as plus 10h, and then my last term I'm going to leave as plus 6h. Now I'm going to combine some like terms here. So we're going to add 10h plus 6h to get 16h, and then I'm going to subtract 30 and subtract 30 here to move that over to the one side. So we can simplify this down to 126 minus 30 is 96 is equal to 16h. So my goal is to isolate the variable. I'm ultimately looking for what the value of h is. So I'm going to divide out the 16, and when we do 16 divided by 16 leaves me with 1h, and 96 divided by 16 is going to leave me with 6. And then go back to your units. Because we're dealing with inches, I know my height is going to be 6 inches. And the last thing we're going to do is look at how to calculate the surface area of composite figures, which is just when we take 2 or more objects and put them together, such as we did here where we have a pyramid along with a rectangular prism. Now in this example, we're calculating the surface area of the tent, including the bottom. So we need to figure out what's the area of that rectangle on the bottom, as well as the 4 sides, all rectangles around the tent, and the top. Now we're not going to include this piece here, because when you're in a tent, you're going to be looking straight up to the roof. So we're not including the overlap. We don't need to figure out what the top area is of that rectangular prism. We also don't need the bottom or the base of that pyramid. I'm going to begin thinking about the pieces we need with the bottom part of the tent. So my base is just going to be 2.5 times 2. That's going to give me the area of the rectangle on the bottom. I'm not going to double that because remember, we're not including that top. We're just going to be able to stand on the tent and look up to the very peak. I've kind of color coordinated this. So we're going to have 2 of this area. So again, base times height of 2 is going to give me the area of those 2 rectangles, and then we're going to have 2 of those side pieces. So I'm going to add those all together, and the bottom and the 4 sides around the rectangle are going to give us 23 square meters. Now I'm going to figure out what are the areas of those 4 triangles on the top. Let's begin by calculating this particular area, and remember it's going to be the same as the area over here. So I've got 2 triangles, and I can find the area of each by going base times height divided by 2, and I'm going to use S for slant height just because it is the slant height of the pyramid. Okay, so we know that if we're looking at this triangle, I know that my base is going to be 2 meters. It's going to be the same length as down here. The height we're going to have to calculate because we don't know what that is. Now, if the entire tent is 3 meters from the bottom to the very top here, and I know that the walls of the tent from here to here are 2 meters, 3 meters minus 2 meters means that the height of that pyramid has to be 1 meter. So I've gone ahead and drawn that in here. So I know the height of the pyramid is 1 meter. And I also know that from the very center of the pyramid to the edge is going to be half of this length here. So 2.5 divided by 2 gives us 1.25. So I'm looking for that slant height, and I've kind of drawn this down here just to see, knowing that my height is 1 and my base is 1.25. Using Pythagoras' theorem, I can calculate that measure to be 1.607, and I'm going to leave that exact value in the calculator. I don't want to round it off until the very end. So I'm going to go back up here, and I'm going to say, okay, the base of this triangle is 2 times the height of that triangle is that 1.6007, etc. And then I also recognize that if I'm multiplying 2 times 1/2, basically these 2 triangles together are going to form a rectangle. So I'm just going to simplify this by 2 divided by 2 is going to give me 1. And then when I go to substitute this in, I can find the area of these 2 pieces by just multiplying the base times the slant height of the pyramid, which is the height of that triangle. Finally, we're looking for the area of these two triangles on kind of the front and the back of the pyramid. So I know again that the base of that pyramid is the 2.5 meters. So I've got 2.5 meters substituted in for the base. And the same concept, we have two triangles. 2 divided by 2 is going to give me one basically rectangle if we were to put the two of them together. So I've got the base, and I'm looking for what is the height of this triangle, the slant height of the pyramid. And so we kind of have to imagine we're rotating. It's going to be the same concept where if I take this back one, which might be a little bit easier to see, I know that I'm going to have 1 meter for the height. So I've got that 1 meter here. And then in terms of this one, you can see that we're going from the very center back that way. So it's going to be half of this measure here. Half of the 2 is going to give us 1 meter. And I just called this S2. We're looking for that second slant height, kind of on the back of that pyramid or on the front of that pyramid. So 1 squared plus 1 squared is 2. So the square root of 2 is that 1.414. So that is the height of that triangle. So I've substituted that in here. And then when I multiply them, I get 3.53, etc. These two measurements added together are going to give me the surface area of the pyramid, those 4 triangular faces. And then I'm going to add that measurement to the surface area of the prism, and I'm going to get the total surface area of the tent. And finally, we have a cylinder and a cone, and we're looking for the surface area of this shape. Now, we're not going to include the top circle of the cylinder or the bottom circle of the cone. So we're just sticking those two together, and we're looking for the area of the bottom, the lateral area around the side, and then this lateral area around the side as well. By understanding how those formulas are derived, we can figure out which pieces of the formula we need. So in terms of the cylinder, I want 1 circle for the bottom, and I can find the area of the circle by pi r squared. My diameter is 19 feet. Divide that in half to get the radius, which is going to give us 9.5. So we're going to calculate the area of the bottom. The area that wraps around here, so we have 2 pi times the radius, which again is that 9.5 times the height of the rectangle. When we unravel it, is going to give us that 21 feet. And then finally, we need to figure out what is the lateral surface area of this cone. So we're going to have pi rs. We know pi. The radius is going to be the same. It's going to be that 9.5 feet. And what we need to calculate is what that slant height is. If the height of this entire composite figure is 25 feet and the height of the cylinder is 21 feet, I can go 25 minus 21, and that's going to give me a height of the cone of just 4 feet. I know that the radius is that 9.5, so again, I can use Pythagoras' theorem, as I have a right triangle here, to calculate what that slant height is, and it comes out to be 10.307, etc. Keep that whole number in your calculator, and we're going to substitute that in here. Now at this point, you can just enter this entire piece into your TI calculator, and it will give you the answer. If you don't have a TI calculator and you're going to do it in pieces, we're going to figure out what are each of these areas, and then we're going to add them together. So I've done that here just if you want to double check your measurements. But the total area is going to be about 1844.65, etc. It doesn't tell me what to round to, so I'm going to keep that exact value. And again, make sure we have square feet as we're dealing with area. One final note, all of my measurements happen to be the same unit. If they weren't, you would first convert them to get them into the same unit. Then you can figure out what are the areas we need in order to get the total surface area.